Tricky. Now it should work. Yeah, now it should work. All right. Yeah, music. Music too loud. Fixing. Easy. So what's the plan for today? I want to do a similar thing as yesterday. So tiny bit of Manim and then we do some gaming. No need for weird WoW farming though today, so we'll skip that part. I'm not sure what we will exactly play though, so it might... I'm kind of unsure whether it might be something actiony like Vampire Survivors, or whether we should swing back and give Baba Is You or so another try. I really liked that game. It was pretty fun. So yeah, we'll see. We'll see. We'll see how we feel after we did a little bit of Manim. Okay, I'm ready. I hope. Actually I'm not, well, almost ready. So let me open up the thing that we will need. Okay. All right, so here's at least the code editor, which is something, right? And basically what I want to do in terms of content that I want to write is more or less this part. So talking about how the initialization of the replacement transform actually works. And yeah, might even be a shorter paragraph than the one we've written yesterday, which was actually quite lengthy. So yeah, that's my plan. I'll fetch some water and then we go. We're back. Now it should be back. Why is this breaking up today? Second time already. Thanks so much for letting me know. I did not look at my OBS right now. That was kind of weird. I hope it stops breaking. That would be really... If that happens... I'll have to rely on chat to tell me. I just want to say I'm planning a... Well... Something that I want to record next week, and if this breaks, I would be kinda unhappy, let's say it. Let's say it like that. Okay, so let's see whether this works as intended. We take a test scene, A equals scene, mob 1. Wait, was I simply silent after I returned from fetching water? Then maybe just forgot to unmute the mic. Then maybe it didn't break at all. Square. Object 2 equals circle. Object group equals group of object 1 and object 2. Test scene add object group. Aha! It returns some stuff here that we have to take care of. Okay. The scene objects is a group. Test scene restructure objects to remove equals. Yo, maybe we play some GeoGuessr. I kinda feel like GeoGuessr. Okay, so that's just a thing again, and then test scene objects is the circle. Okay, so after the add and after the restructure objects method, the scene is returned. So we should take care of that. Let's add that. So that was here. So we need to add something here and we need to add something here. What exactly do we need to add? Manim scene. And we will ellipsis the memory address like that. And that should be the same thing again. Okay. Great. Now the thing that we have is even correct, which is better. And otherwise the output was okay, right? Here we have the group and here we have the circle. Yeah, that's good. It's fine. Just like we wanted it. Okay. Let's commit that actually. Fixed example. Good. Good. Let me quickly check something. All right. It's fine. Okay, so let's look at the animation that we're actually rendering again, just to get a feeling for what we have to write now in the replacement transform part. Manim. Actually, just run Python toy example. Go. Rendering. So this is our test scene. This is the scene that we are basically walking through. And so far we have explained, I think, everything. We haven't explained how this frame actually is constructed. And that will still take some time until we do that. But in terms of what we are going to explain next is this animation here that's played. So this transformation between the orange square and the blue circle. This is what we want to explain next. Did I somewhere write orange circle? I kind of feel like I did. Wait. Orange circle? No. Blue square. Okay, also no. I feel like that's something that might happen quite easily to me. They change the colors and the shapes. Who knows what a circle is and a square? It seems advanced knowledge. Okay. So, we have explained everything up until this line here. In our toy example, this means we have initialized the square and the circle. We have added the orange square to the scene, which is actually not that spectacular. And now the next part is this line here, which is actually quite substantial because all of the logic that is reused in the rest of the scene is basically occurs in this scene. So the play call is the substantial part. The not so substantial part is what I want to take care of today. Namely, I want to write what exactly happens when you call the replacement transform, or when you initialize the replacement transform. And to do that, we will open the corresponding file and take a look. Or is it worth sharing a few details about animations in general before we do that? It might be. Yeah, actually that makes sense because up here I explicitly mentioned that we now talk about the base animation class. So let's look at animation.py, where at some point the animation class is defined. Right. So the defining character of an animation is that A, it has a fixed time span, and B, is that actually true? I know that some animations don't necessarily have a fixed time span, I think. I've never used the ones that have a variable one, to be honest. Where is the... Wait has to be here somewhere. Wait has a stop condition. Overrides the specified runtime. So actually an animation is not necessarily something that has a fixed runtime, which is confusing. I think what I want to say about animations is that they are always attached to an object. And then I don't think that there's much more to say about it. Maybe we'll mention some of the special methods of animations. So that in the beginning, the begin method is so as a part of the render loop. First, the begin method is called, then basically the object is updated. Not updated. The object is interpolated. Yeah. This is one of these weird methods that I'm not really sure why they actually have to exist. Set runtime, full-blown method, which simply sets the runtime attribute. Doesn't do anything else. Get runtimes, same thing. Not sure why there need to be setter and getter methods for these. But well, it is how it is. We don't change the implementation here. Get rate function, set name, zoom over, zoom user. Okay. Before we follow the trace of the debugger. Wait, have I written it before? Let's briefly follow the trace of the debugger. Okay, okay. I can write it twice in an article like that. That's fine. That's fine. Okay, before we follow the trace of the debugger, let us briefly discuss the information that is stored, or let us briefly discuss the general structure of the abstract of the, I'll put abstract in parentheses again, base class animation. To an animation class object holds all the information necessary for the scene to generate the, or for the renderer to generate the intermediate frames such that an frames that actually make up the animation, or that make up the visual. That's so weird. An animation object holds all the information necessary for the renderer to generate the corresponding frames. Animations in Manim are always tied. Animations in the sense of animation objects in Manim are always tied to a specific object. Even in the case of class animation group, which you should actually think of as an animation on a group of objects rather than a group of animations. Does it make sense? It sounds fancy. Moreover, by default, except for in a very particular special case, the runtime of animations is also fixed and known beforehand. So there's just I'm basically only aware of the wait object, of the wait animation that has a mechanism where you can extend the wait until, well, however long your condition is evaluates to false. Okay. In a very particular special cases is like overloading a little bit too much. Except for in a particular special case, the runtime of animation is also fixed and known beforehand. Animations have a few special methods. Do I just start a list here and then talk about each of these methods that I want to talk about one after the other? Probably. I mean, there's a few special methods which are called during the render loop. Minus. Animation update config is called at the beginning of each frame and is used to update the configuration of the object to which the animation is attached. Where does Copilot get this from? I don't think that there is an animation.update config at all. But the sentence is very... I tried something like that. If there was a method update config which was called at the beginning of each frame, then yeah, then I would write it exactly like that. But I don't think that there is. There is no update config method. I like it when Copilot makes up stuff. .animation.begin. Which is called at the beginning of the animation and is supposed to set up the animation. Exactly. Which is called as hinted by its name. At the beginning of every animation. So before the first frame is rendered. Animations have a few special methods which are called during the render loop. Before I actually talk about the special methods, I want to say something about the initialization of animations, because that's not too exciting in most cases. In most cases, the initialization only stores the properties that or only stores the things that you pass to it, the arguments. It only stores them in the appropriate attributes and maybe does some easy calculations. But everything else in the lifecycle of an animation happens later, right before the actual animation is played. And I think that I should say that at some point. And here seems to be a good case. The initialization of animations actually is not particularly... Wait, it's not... How often do I use particular? Wait, my headset is beeping. Done. Okay. Cable. Wait, cable is doing something weird. It's fine. It's fine. Maybe it's fine. Fortunately, you don't see the cable mess that I have in front of me. Okay. is not very interesting, Copilot suggests. Should we go with that? I think we should. Yeah, it's not very interesting. It's not very exciting, I actually wanted to say. Exciting. Is that even true? Wait, let me check that this is true what I'm saying. Let's check the initialization of the init function. Starting object, mobject. Yeah. Yo. Ram69, thanks for following. Yeah, so this here only attributes are set. There's nothing exciting happening here. This part here, something slightly exciting is happening. Yo, Rimpuru, thanks for following. This part here, something slightly exciting is happening. The starting object, the correct one, is set basically. It's kind of interesting that this is always set to a blank object. It's kind of weird. Why would that happen? And the begin method probably changes that then. Yeah, it calls the create starting object method. Why is it set to something that's not... Why couldn't we just set it to none? I don't quite understand why we need to initialize an object there, but well. Yo, Dakush, thanks for following. Where are you guys coming from? 3 follows within a minute is kinda rare. But I appreciate it, of course. Bulgaria? That was Bulgaria actually is is the question I asked was meant less literal actually. More in the sense of how did you find my stream, but yeah. From your Matura videos? Oh, I'm looking forward to the Matura in 2 days in the week, 9 days. I mean, I'm looking forward to doing the stream. It will be fun. I usually enjoy it. Let's see whether the Matura actually itself will be interesting. So in case anyone unfamiliar with the Matura stuff is watching, Matura is the Austrian school leaving exam, and I, for some reason, I enjoy doing that whenever it's released, and that will happen on the 3rd of May in the afternoon, and then I'll stream the exam. We'll see whether that will be fun as well. I mean, I usually enjoy doing it. It's always a question how exhausting the exam is. I did actually think about whether it would make sense to do both the AHS and the BHS back to back, but experience shows that after doing the AHS one, I'm too defeated to even do anything well, even slightly complicated. So I guess that won't happen. But yeah, at least the ones for like general schools and stuff, we will do. Fun. Are you guys writing the Matura? Oh yeah, I should maybe also have said what Manim actually is. So the thing I'm working on here is like an animation library If you've ever seen some well, math population or popularization of math videos on YouTube, you might have stumbled across 3 Blue 1 Brown. And basically it's the library he started to write. And if you want to see an example of what it can do, a very simple one, of course, but a very simple example of what it can do is this one here. So it's a transformation of a square into a circle, and then stuff happens. I'm currently writing a tutorial of what exactly the library does to produce this sort of video output, which is super helpful, I hope, for people, because that's actually quite hard. The library is well, not particularly well documented, let's put it like that. And yeah, so I know that's not the most exciting content to stream, but it's important work, and sometimes people stop by and chat a little bit with me, and I usually enjoy that. I can show you stuff actually, if you're interested. I did some things recently. Are you doing it for fun? Yeah. I'm doing it mostly for fun. Sometimes I'm even having fun. The library can be frustrating at times. I created a thing recently. Let me see where I can bring it up. Yo, and also stuff like the waiting screen that you have behind me. That's also made with Manim. That's maybe slightly more interesting. But I can show you 1 or 2 examples if you really wanna see what the library can do. Yo, Nagisa, thanks for following. Let me just minimize that, and then I can actually open stuff here. Yo, so this is... Oh, you can't see, wait. This is... Oh, wait, let me actually... I hate when my play and pause button doesn't do the right thing. Let me pause the music here, and then I can start the video here. Yeah, of course. Video, where you go? Why? Stay here. So this is something fun that I did recently. It shows an example that's well known in the context of self-referential sets. And basically what you do is you start with a point, and then you have 4 rules that you choose randomly according to these given weights here. And you choose a rule, draw a new point, choose a rule, draw a new point, choose a rule, draw a new point, and repeat it. And if you repeat it then often enough, which, well, the first 10 or so I did slowly, and then the rest I did a little bit faster. What happens is that the fern emerges, which is interesting, I think, because it's not really something that you would expect to see from well, these 4 simple linear equations that you have there. But we can actually explain why this happens in this way. So that's one thing I did, and I can show you a second one maybe if you're still here and interested. Let me show you a second one as well. That's pretty nice, thank you. I enjoy doing that from time to time. I mostly actually just work on the library, and I rarely get to do animations myself. But whenever I do, it's usually fun. Yo, look at this. This is the second one I can offer. Is there music in that one? We can simply remove the music, it doesn't matter. This shows the dragon curve. If you have ever seen, or if you ever looked into fractals a little bit, this is also one of the most well-known examples. You simply draw a line and repeat the step of duplicating and rotating a lot. And if you do it often, then again, some sort of fractal structure emerges. which I think is pretty fun. Almost looks like a seahorse, but in reality it's a well, it's called the dragon curve. You can see that's the, for me that's the most fun part of the animation, where I've basically just traced the beginning of the curve to the end of the curve with this red segment there. So it traces all of the way how the path goes from start to end. And with Manim, you like program the animations? Yeah, exactly. So the advantage of Manim is that it's a programmatic animation library, and you just write some code and then that's what you get. I have some stuff on my so these examples I just showed you I also have on my YouTube. And if you click on the video descriptions there, I also have the associated code. It's usually not that much even. I think these last few examples that you've seen must have been like, I don't know, maybe like a... I should be able to open one of them. Yeah, the fern, the last one I showed you earlier has like 100 lines of code even. Yeah. And it's not very cleanly written. I'm whenever I do these kind of things, I start out and would like to have a more or less clean code for the animation, but at some point I don't know. I have to use ugly hacks to make the things work, and to have the things working as I would like them to. Programming moment, yeah, exactly. I usually start with a like really clean idea in my head, and then at the moment to be fair, it's a lot of the time it's also the library's fault, because it's not. Library can be a bit tricky to handle at times. So basically, most of it, the foundation of it, basically has been written by Grant, so Free Blue Ron Brown himself. So it's a one-person project, and it's also documented and worked like a one-person project. So lots of dead and broken code, lots of simply undocumented stuff. Inheritance, the general data structure is not as neat as it could be. So yeah, and what we're doing, so a little bit more actually it's almost 2 years ago at this point, a small community has formed that has started to maintain this stuff, and I'm one of the maintainers of this community. So I try to keep an overview of how things work and what's happening with the people contributing and reviewing their code, and yeah, also writing stuff myself, obviously. When I started the group that I worked, the assignments would be had to present the Mandelbrotmenge, which calculated an n-squared picture for immense. Each frame was done in one CPU for one gimmick, which you can click in the picture and get a recalculated and present. That's pretty cool. That's pretty cool. So I really like these. I really like these sort of well, interactive things. Manim actually also has some capacity for interactivity. I actually, one of the things I do is I produce a video tutorial series for Manim on YouTube. So I don't even know, do I have a... Oh wow, when did I write that? I have no idea. Almost done in Java, which is flying over my head. Java sounds also fun for something like that, yeah. I mean, maybe the user interface is kind of accessible with that, but yeah. No, I do like these sort of fractal things, and yeah. Trying to learn PowerShell and Python at the moment. Yeah, so if you want to learn Python and have a basic understanding of the syntax, I actually do recommend maybe take a look at our interactive tutorial for Manim. It's at HTTPS try Manim community. I think the Java Code Simulator. Yep. I think the library can actually be a good motivation for trying to learn Manim. It's not great if you learn Python by looking at how the library itself is coded, but that's actually a terrible idea. I would not recommend that. But if you're using it, the user interface is kind of okay, and actually it makes you understand a lot of things, and it makes you like try to write stuff with lists and all that sort of things, and in a sort of efficient way. So yeah, if you ever wonder about that, maybe take a look at the interactive at our interactive tutorial. Yeah, and the thing I did recently on YouTube was exactly an episode on interactivity in Manim, which works to some degree. I could even show you. I could even show you an example, I think. Do I have something? I don't really at the moment. Wait, what's tree? Ah, I know what tree is. Wait. You want to see something fun? Manim has the opportunity, or Manim has the feature that you can write custom shaders for it. So there's an experimental support for rendering with OpenGL, and you can pass your own shaders for that. And if you like really go overboard with that, then you can do stuff like that. That's not easy to do, by the way. That's really something very, very particular. But in theory, Manim can do that as well. It's pretty late. I'm gonna head out. Have a great stream. Thank you very much. Thank you very much. Thanks for watching and following. And yeah. Hope you enjoyed your stay so far. Had to learn assembler, C, C++, Java, PHP, and nothing really stuck. Yeah. I do like these like more low-level languages as well to some degree. In terms of the work that I usually do, so I'm a mathematician. I work at university. In terms of the research work I do, I mostly use scripting languages, so especially stuff that interacts with well, some sort of computer algebra system. And for these, I really like Python actually. I'm not even sure. The main reason I fell into Python basically was because I used SageMath a lot. So SageMath is a free and open source computer algebra system that's written on top of Python. I wouldn't say it's a Python library because things are more complicated than that, but it's built on top of Python, and you can interface all sorts of different mathematical libraries with it, which is pretty, and I like doing that. So it's this sort of coding is fun for me. Oh well, I should get back to writing. Otherwise, I don't ever leave this part of the stream. And I do wanna switch to gaming at some point. At some not too distant point in the future. But yeah, if you have if anyone has any questions about Manim, I'm obviously happy to talk more and show you more examples. Maybe if you wanna see some. Oh, the interactivity stuff. Yeah, basically I can actually... There should be a scene that I can use, a ready one. That's one thing that I sort of mentioned, and that I should at least show you something. Where is it? This one. Text test. So Manim QM renderer OpenGL QMP open GL text test. Manim not okay. Manim, do your thing. So what you can do is you can issue a special command, and then with this live render preview window you can interact actually. So you can change the camera by moving the mouse around, you can zoom in, zoom out, and you can even do some more fancy stuff. So like actual interactivity. I had one example in my video which I found was really nice. Actually, if the code's still here for that, so we could take a look. What's it called? Newton iteration. Let me show you. Episode 5, Newton iteration. If you've ever heard of Newton iteration, it's a procedure to find the roots of a polynomial, so the zeros, wherever the intersection with the axes are. And with the interactivity, with this interactive feature of Manim, what you can do is you can program the scene so that it listens to mouse input, basically. I have two commands, I think P and I or something like that, I can't remember exactly. Whenever I move the mouse like on the graph to say here or so, and then I press P, then it animates the point, the movement of the point here to wherever the mouse was, or wherever the mouse was on the position of the graph, the corresponding projection. And then whenever I press I, it does one step of the Newton procedure, which basically works like that. You draw a tangent to the graph, and then you intersect the tangent, the straight line, with the x-axis, and then you project the point to the graph again. Sounds difficult, but it's all that happens is this. Straight line, moving the point, projecting it up. Straight line, moving the point, projecting it up. Straight line, projecting it, moving the point, projecting it up. And so on, until we reach something that's pretty close to 0 already. And I can do this with well, any points here. It's none of this has been written before I did none of these animations that you just saw were implemented before. It does that live. So I can also do it like, say, here on this side. Point moves here. Tangent, intersection, projection. Tangent, intersection, projection. Yeah, and that's stuff you can do with Manim. It's pretty cool actually, because it gives you a very visual feeling of how things happen. Yo, Meeps, thanks for the raid. Thanks for the raid. That's pretty sweet. How are you doing? What's happening? What have you been streaming? Looking forward to your Matura stream? Yo, that will be fun. I'm looking forward to that as well, actually. Thanks for following, not Meepsy Meeps. The new Kirby. Ah, that's fun. I've been looking into that. I don't have a setup to stream for my Switch right now, but I do like the Kirby games usually. They're pretty fun. Good stuff. Yo, so I've just been talking a little bit to people about the work I'm doing right now. So one of the things I do on stream is I work on Manim, which is a animation library in Python. And one of the things you can do with it is this sort of stuff. So it has an interactive feature where you can illustrate stuff. It's pretty fun. I mean, when I play animations like that, it's pretty fun. If I just document stuff, it's not that much fun, obviously. But yeah, people get interested in that from time to time. So if you've ever watched some math videos on YouTube or so, then it's quite likely you've run into Free Blue Von Braun, and that's basically the tool he uses to create his videos. Can you draw a Kirby? Theoretically, yes. Theoretically, it should be possible. I mean, I can import an image. That would be easy. And with stuff like Wolfram Alpha, you can draw the associated curves, and then I could also draw that in Manim. Wouldn't be too hard, actually. Wouldn't be too hard. But yeah, the image version is probably the... Oh, that was a slight bug. I was too fast with changing. Yo, but I really like these sort of animations because they really... I don't know, they help to visualize all sorts of stuff. And the only thing that I would like even more about this is if other people could use this interactivity feature as well. Right now it's mainly I have to do stuff. Your Matura stream will be next week or so? Yeah, exactly. On the day of the Matura. So it's the Matura is on Tuesday next week, so the 3rd of May, and I'll be live a little bit before the official before the exam is online. So the exam is online at 4 p.m. Central Europe summertime, and I'll be live a little bit before that, and then we'll do it. So yeah, that will be fun. Looking forward to that already. Nice. Yeah. It will be fun. It usually is. I'm already slightly afraid of all the possible blackouts that I can have, and in the last Matura I did. I think I swapped the sides of a triangle, or actually I didn't. I had the definition of the tangent wrong, so I think I had sine over cosine over sine, and then all of my measurements were wrong. I had the wrong angle basically, which was pretty fun. I think there was some stair with an absurd angle, and I was like, yeah, okay, seems fine. 60-degree angle for the stair, why not? Sure. I'd like to suggest a kangaroo stream too. Ah, that's a fun idea. I'll put it on the list. That might happen. Can you are the kangaroo exams? Can you find those somewhere? Okay, let's close this down. Yo, if you want to see another fun animation, I'll play the should be all online, I think. I'll take a look. If you want to see another fun animation, so if you're wondering what sort of things you can do with Manim, this screen right here. I just showed this before as well, but I think it's this and the dragon curve are so fun that I actually want to show them again if there are new people here that wonder about what I'm doing. So this is something that you can generate with the library, and this here as well. It's an example that shows how to generate the dragon curve, which is a more or less well-known fractal. You basically draw a line and then you copy everything you have and rotate it by 90 degrees, about the last point of the line. And if you repeat it and repeat it and repeat it, and repeated and repeated and repeated more, and some 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 more. You end up with something that's really, really nice. And it looks like a dragon, almost. I mean, it's called Dragon Curve, so it better look like a dragon. Is it just a binary counter? You mean the animation with the paths? This one? Not really. These paths are called like paths. They are pretty elementary combinatorial objects. Basically, you have a start point somewhere on the axis. You take a number of steps, either up or down. You want to end on the axis again, and you never pass below it. And these are, well, exactly these. And the animation that you see behind me is basically an enumeration of all, I think it's 429 paths of this particular length. It iterates through all of them, but in a sort of chill way. I actually also have a short animation that goes a bit faster if you're interested. I'll just show it. There we go. Just moving the stuff. Look at this. Blah, blah, blah. Yeah, so there you can see how it's actually very familiar to it, or it's related in some sense to the binary counting, but there are I would like to say fewer paths of that satisfy that sort of thing. So not all of the 2 to the n, whatever n actually is, paths are valid ones, because if they were, then they would also go below the axis. Looks like it's iterating something left first. Yeah, you're not entirely wrong. You're not wrong. The generation works in the way that basically it moves the hill, so this hill is moved more and more to the left. So first it moves it moves the first hill down right, and then it continues. That's probably actually not. It doesn't move it left. It moves it right. That's an easier way to see it. So first you have this one, and then one further to the right, one further to the right, and so on and so forth. And that happens again and again and again and again. That's the similarity to this binary counting that you might see, because it always shifts this peak here like to the right, and again and again and again. So with the next one and the next one and the next one and the next one, and it repeats it until at some point all of the possible paths are enumerated. So yeah. That's the sort of things you can do with Manim, and that's what that's what I'm that's the library I'm working on. Does look nice? Yeah, it's oddly soothing in a weird way. Generating these sort of animations is like that's something that I enjoy quite a lot. It's just so, I don't know. It's very enjoyable to work on these sort of things and visualize I work a lot of the time I work with these sort of paths. So lots of my research revolves around paths that look like that or look similar to that. And that's why, yeah. That's why it's very enjoyable for me to work with these in an animation context as well. Anyhow. Yeah, so my Matura stream will happen. Next week. Next week on Tuesday. Not this week. So not this Tuesday, but the one after it, 3rd of May. What book or resource did you use to learn Python? Ooh, that's a good question. That's actually a good question. I learned Python mostly by working with Sage Math. When I learned programming a few years ago, I started with Java because that's the intro course to programming taught at my university, or at the university where I studied at. And after that, I didn't learn Python immediately, I think. It took a while. But then at some point I picked it up and it felt so natural to do all sorts of things with Python. And it's definitely the language I write the most these days. By far. But I can recommend, so I usually over the past few years, I've taken care of interns at our summer interns at our department back in Austria. And what I usually do with them, it also revolves around, well, programming a little bit. Actually, the past few years they have been doing Manim even. And what I usually recommend for them is something like Codecademy or Free Code Camp also has a bunch of stuff, I think. I'm currently abroad, so I haven't mentored interns for a while now. But the last time I did, I definitely recommended Codecademy, I think. There's tons of good resources out there. I wouldn't necessarily recommend to learn with the official Python documentation. That's kind of tedious. But Codecademy is pretty good, I think. All sorts of any sort of exam, or I don't know. For me, really learning Python probably mostly meant trying to do lots of short exercises, because yeah, that's I think how you actually learn programming the best. So I really like the Advent of Code challenges exercises. Yeah. I wanted to learn Rust recently, because I felt like that's something that's very modern nowadays. So I wanted to learn that, and I haven't done anything with statically typed languages in a while. So I felt like it would be really fun to get into Rust a little bit. And then I think I did like 2 or 3 days of the Advent of Code this year. And every time I did an example, I was simply so annoyed, because I knew if I did that in Python, I would be done in like 10 minutes, if even. And in Rust, it took me, I don't know, an eternity to read the input incorrectly, to debug all sorts of things that I did not understand about passing or casting the types correctly. And so I got really, really frustrated and then stopped, which is, well, not particularly great. I can write some Rust now, but it's really, my abilities are limited, I would say, at this point. Short enough to do and hard enough to learn stuff, as well as not having to think too much about coming up. Yeah, exactly. There's a sweet spot between exercises that are fun to work with, because you exactly know how you do them programmatically, and you don't have to think about you don't have to come up with an algorithm, and something that's not, I don't know, if it's too easy, I don't think it makes sense to I don't feel motivated enough to actually tackle the problem and solve it with the language and write some code for it. It is hard if you know programming to remember how it feels to learn stuff. Yeah, exactly. It's hard to estimate what's hard if you're learning. Yeah. I completely agree. Yeah, so the Advent of Code with my advent of code with Rust adventure was kind of frustrating, to be honest. But I think I'll pick it up again, maybe next year for the next year's advent of code. I might even do it on stream. I think if my life hack these days is all the things that I find boring or that I'm not motivated enough about, I simply do it on stream, because then sometimes people stop by and well, chat with me, help out a little bit, and it's much more enjoyable for me that way. It's kind of selfish, but yeah. That's how the world works. No, but I do really recommend the admin code stuff. One resource I learned, I can remember that now. One resource I learned as well. There was a website called HackerRank. I'm not sure whether it's still up and running. It also was in similar spirit. Lots of small examples where you could more or less easily. There were some exercises that were really hard and where you had to come up with something smart that you did in order to solve it correctly. But I think like challenges like these usually motivate you in some way to keep learning. That's the deciding factor in the end. I also think that if you learn programming like in a course at university, it's usually the course really doesn't matter that much actually. What matters is that you have some reason to keep learning and to keep being invested. The resource and the exact material that's taught is usually not that relevant. At least that's well how I see it. Yeah, so I did give lectures on programming with Python and particularly computer algebra, so Sage. There's one course that we have in Klagenfurt. It's called Computer Mathematik, and I have done that several times. So that's usually in the way it was before, it was one of the first points of contact of students with any sort of programming and computer algebra. So I taught that several times, and it's usually quite fun to work with people to get them invested into programming. But it's hard to choose appropriate examples. You can't give something too hard and too complicated, because otherwise people will be frustrated. Can't give something too easy, because then nobody learns something. It's hard. Yeah, lots of people get really proficient with Excel, for example, which program too. Yeah, absolutely. Excel can be. The difficult part about Excel sometimes is debugging it. I've had it several times that I had to edit some more or less complicated spreadsheet, and sometimes there would be errors in it, so the result, that the output cell would be simply wrong. And then going back and seeing how formulas might be wrong, whether there was like a fixed cell that was not applied correctly or something like that. That's really painful, at least for me. I don't know. I rather read like a 50 lines of code Python script that does the same thing. Maybe wrap it around in a small web application or something like that, and then have that run somewhere instead of working through and debugging an Excel sheet. I don't know. I can't really get warm with that. It's forcing me to do Excel is in the long term very, very hard for me. It's good at hiding code, which while a lot of programming languages are really good at hiding results. And yeah, you're completely right. I think that's very true. That's true. So if you have some sort of Excel sheet, then inspecting stuff in between is not particularly difficult. It can be much harder in actual programming languages. But in contrast, yeah, it's hard to see how things actually happen and actually find out the flow of a calculation. That can be quite difficult, and that's easier if you have like a page of source code that you can read. True. I agree. I still suck at a lot of at actual debugging with the debugger, for example. I've gotten so this I would say this was true for me as well before I started doing more work with Manim, but there are so many weird bugs in Manim that I have to use a debugger quite often to actually see where stuff is happening, and I think also switching from I was using Emacs for the longest time. Switching from Emacs to something like this, so right now I'm using VS Code. This switch has helped me to do debugging a little bit easier. I could have done it in Emacs as well. I actually have set that up more than once even. But I don't know. For debugging, I simply prefer a user interface and something that's looks nice and looks like it wants to help me. Xlet would be probably a part of my workflow, even to do something in smaller steps, since it wouldn't make sense to build a server. Yeah. No, it doesn't make sense to build these very large formulas. It's much better to in Xlet it's much better to split things apart as much as you can, because it also makes debugging much easier. I had a friend come to me with something that looked with a formula in Excel that looked really frightening and terrible, and that was basically because there were so many it was a spreadsheet where some computations about demand and price of some articles happened, and the weird thing in there was there were so many weird corner cases, and all of those were encoded into like this gigantic formula, and it took us a substantial amount of time to unravel that somehow, and lots of copying the code from Excel into an external formatter, looking at stuff in this separated environment, and then deciding well which cases correspond to what. Why is that even here? Ah, it's reset in the begin method anyways. Create starting object. Yeah, it just copies the original object. That's... I don't know, that's weird. That's kind of sketchy to me actually. Why is that not set to none in the beginning? Should we say something about that? Maybe. Copilot also wants me to say something. Once the animation is actually displayed, the starting object attribute holds a copy of the initial start of the unmodified, holds an unmodified copy of the object the animation is attached to, and the object attribute holds the eventually modified version. Now, it's kind of complicated to read. Sentence is too long. Once animation is played, blah blah blah. During the initialization, it is set to a placeholder object. The object attribute is set to the object that animation is attached to. Yeah, that's fine. That's fine. Maybe too complicated and too detailed. I'm not sure. Maybe we'll cut that out. Maybe we'll cut that out eventually. We'll see. We'll see. Okay. Is there anything else? Anything else that's interesting that's happening here? Starting object, set of object, debug for additional keyword arguments. Doesn't matter. Config has been passed. Right. No, that's fine. Nothing else happens in the initialization. Okay, now we can talk about the special methods. Animations of a few special methods are called during the render loop, which is called at the beginning of it. So we first talk about the begin animation, which is called at the beginning of every animation before the first frame is rendered. In the default implementation, I think the begin method only correctly sets the starting object, which again, I'm not sure why this happens here and not somewhere else. And then it calls the interpolate method. Init all the required setup for the animation happens. Usually no, I don't think I want to say more at this point. It's fine. Second method is animation.finish. Is the counterpart to the begin method, which is called at the end of an animation, of the life cycle of the animation. Is it called before or after the last frame has been rendered? I wonder. Actually don't know. I should know that. I won't see it here. I need to check the scene. Render play internal. That's the main method that does the updating. And what happens when time progression close, finish, clean up from scene. No. So okay, so it's happening after the final frame has already been rendered. Except if the time no, but the time progression closed. That's not related. No. Nothing here calls the renderer again. The renderer works here. And it doesn't work afterwards. Renderer static images, no. It's actually just after the last frame has been rendered. Which is called the end of the life cycle of the animation after the last frame has been rendered. Okay, so we have the begin method, we have the finish method, and now we need the method that actually does the work, the interpolate method. Animation.interpolate. Which does what? So the default implementation is that it calls interpolate object, but it could be overwritten. I don't want to say too much about this actually. I think I'll just mention that the parameter alpha that's passed here is like the is it wait. Isn't interpolate the parameter is that the percentage to which the animation is completed. We'll check. We'll have to check again. Update to time t. That's the thing that does the updating. Animation interpolate alpha, and alpha is t over animation runtime. So yeah, alpha is the percentage to which the animation is being completed. Interpolate is the method that updates the object attached to the animation to the corresponding completion animation completion percentage. For example, if in the render loop animation.interpolate, actually changes to some animation dot interpolate of 0.5 is called, the attached object will be updated to the state at 50% of the animation complete to the state where 50% of the animation are completed. Yo, sicher nett. Nice to see you. How are you doing? I'm fine. We've had lots of people here earlier, and I showed off some Manim. Some of them enjoyed it, I think. And then I started doing, well, writing paragraphs again. But I think I'll be done. I'll be done with this particular part in a moment, then we finally switch. Because it's Sunday evening and I should do something that's not work at this point. This updates the object attached to the animation to the corresponding animation completion percentage. For example, if in the render loop some animation interpolate 0.5 is called, the attached object will be updated to the state where 50% of the animation are completed. Nice. Pretty good, just a dinner with family. Now I'm packing up stuff for going back to Graz. Safe travels. You're going tomorrow, I guess. At this point, it's impossible. I mean, not impossible, but at least by public transport. We will discuss details about these and some further animation methods once we walk through the actual render loop. For now, we continue with our example, with our toy example and the trace of the debugger when initializing and the code that is run when initializing. Oh, I wrote it correctly. When initializing the replacement transform animation class dot. Good. We wrote some stuff. Should we do more? I don't really want to. I think not impossible, but it would take 7 hours, so going tomorrow morning. Yes. I mean 7 hours also almost is tomorrow morning as well. No, but tomorrow morning probably makes more sense, yeah. Good. So I think we'll commit this and let it be. Should this be a separate section? Probably not. This is still fine in one section. First we talk about the general group, and then we be more and more specific until we reach this point where we actually discuss the replacement transform. Yeah, I think that's fine. I think it's fine. And I mean, is there much that happens during the initialization? Probably not. Transform, let's see. Let's see. If there's not too much, then I'll maybe just write a few lines and then be done with it. Class replacement transform, there we go. Yeah, okay. So replacement transform basically is a transform where we pass additionally the keyword, the keyword argument replace object with target in scene equals true. I think we can write that. The initialization of the constructor of I want to avoid a constructor. Initialization method of replacement transform consists of a single line, which is probably not true because the line is too long. Yeah, it's 3 lines, but only consists of a car to the constructor of its parent. I think it's fine to use constructor here and there. Parent class transform with the additional keyword argument replace object with target in. Was it like that? I forgot. Replace object with target in scene. In scene set to true. Great. The transform animation is not much more exciting. it stores a few things, namely these path arc attributes, which are not that exciting actually. The path function and target object. I think I might want to explain what the transform animation actually does. Or should we do that then all at once? Probably not. Probably not. So we might want to explain information about how points from starting object move to points of target object. Class transform, then sets attributes that control how the points of the starting object are moved towards, are deformed into the points of the target object. And then cause the initial, then passes on to the initialization. No, it doesn't look right. Initialization. That looks right. Method of animation. As mentioned above, all other basic properties of the animation like its runtime, the rate function, etc. are processed there, and then the animation object is fully initialized. Done. Do we want to say more? I don't think we want to. I think everything else we maybe get into later. Or maybe I include a hint regarding the actual transformation. Let's include a hint. To replace an object in target with target and scene, keyword argument is used to indicate that an object to be replaced. What is Copilot? Wait. What? The replace object in target with target and scene keyword argument is used to indicate that the object to be replaced is to be replaced with the target object in the scene. I need a GitHub Copilot emote. This is necessary for the replacement transform animation, which is the only animation that actually replaces the object in the scene. That's not true, but okay. I take it. Oh, what is this thing doing? What is this thing doing? No, what did I actually want to say? Should we just say the actual animation or the actual interpolation? I think I'll say we will discuss that later, because I'm not sure how much sense that makes if I now go into details how the points are actually interpolated. Or maybe one paragraph about transform. The mechanism behind the mechanism behind the transform anime. No. I need to be more specific. The way how class animation, transformation, transform deforms objects is. Have I used a nutshell in this already? I shouldn't use more than one nutshell. I know people will be. I know some people that would be unhappy if I use too many nutshells. The way how it deforms an object can be explained is from a high level, not too complicated to explain. The relevant code is in transform dot it's a method. Transform dot probably interpolate subobject. Transform. Oops, what did I do? Oh, I enabled git blame stuff. Can we have that? How did I enable it? Go away. Interpolate subobject. Yeah, it's actually very simple because the objects themselves know how to interpolate between them. The relevant code is in method transform interpolate subobject, which in turn is called by the transform dot interpolate. The relevant code is in interpolate subobject, which is called by the transform interpolate method. And it basically calls it simply calls the. Now it's getting complicated because there are so many interpolate methods. Object.interpolate method, which constructs the interpolation between two objects by drawing straight lines between are control points of the Bézier curves that make up the vectorized object. The Bézier curves that make up the vectorized objects. I have the feeling this, what I'm writing right now, is way too detailed. Basically, what happens is you have your control points on your objects, which is the points through which the I think it's not even that complicated. I think actually it just ensures that the number of points for both objects is the same, and then it returns the convex combination between the 2 points, more or less. So I think I should not mention Bézier curves at all. Which in the default case constructs the appropriate convex combination of the point arrays of the points arrays of the 2 of the starting and target object. This means that do I want to explain that? I'm not sure. Do I want to explain convex combination? I should. Formally speaking, this means that if math P1 if math P and math Q are the point arrays, math alpha P plus 1 minus alpha Q is returned. Geometrically, this means from a visual point of view, imagine that there are straight lines drawn between. Actually, it should be different. I think it should be 1 minus alpha here and 1 minus alpha here and just alpha here is returned, where math alpha is the animation completion percentage. From a visual point of view, imagine that there are straight lines drawn between the control points, between the, I just put points, between the points of the two objects. The interpolated object is obtained by constructing the point at percentage alpha That's still so complicated. I feel like I feel like I have to say more and more to actually make this clear, and that's not a good sign. That's never a good sign. I'll finish the sentence, and then probably next time we work on this, I'll delete it again, because I'm not sure this is really helpful. Interpolated object is obtained by constructing the point at percentage alpha. And this actually is not even entirely true because it depends on the rate function. No. You know what? We scratch this immediately. We scrap this. I don't think this will make it. I think it's fine. We talked about the way how these are initialized. We will talk more about these special functions and what exactly happens in the second part, which we will write next time. I don't want to go into detail at this point. I think it's fine. Yeah, I think that's fine. And next time we will deal with the play call. And then the animation object is fully initialized. It's fully initialized and ready to be played. And then we enter the play car. The play car. Manim's render loop. That will be the section that we will discuss next time. I think that's good. So we initialized the animation. We said some things about important methods that will be called, and then everything else now everything is initialized. We are right there, and next time we will actually head into the play car. So we will head into what happens immediately, the scene caching stuff, yeah, all of the things that I've written here. We will probably split this up in like 2 or 3 sections or so, but in general we will step through all of this and then explain step by step what exactly happens at which point, and then I hope we will be happy. I hope this will be still readable and something that people want to consult. We will see about it, obviously, but yeah, that's what I hope at least. Okay. Any more questions? Do you want to see fun animations again? I kind of want to play more fun animations. But do I have any? I'm not sure. I think I've shown all of my fancy ones already. We could watch a random free blue and brown video, but actually I should just stop the Manim part for today and go and do some gaming. Update initialization of animation object. Good. And you know what? Let's actually also merge the latest main branch, because there were some changes here and there, and there can't be any conflicts, but I'd like to be in the latest version, so to say. Git fetch origin main. Git merge origin main. Yep. Oh. Should have done it down there. I'm not sure why I did it up there. It's kind of weird. Git log. Yeah, it's fine. We push. Okay. I'll do the same thing as before and leave a comment again remarking what we did today. "600 lines. Who is gonna review that? Someone has to proofread it. And I'm not sure I can do that. I mean, I can obviously read it myself again, but yeah, we'll see. We'll see. You know what will be the actual painful part, chat? The painful part will be doing this thing again for the OpenGL renderer. I mean, we don't have to change that much, because lots of things are the same actually. But it will still cost a little bit. Some parts are substantially different, and especially the rendering part will be quite different. But to be fair, I mean, we haven't written that at this point anyways. I actually think most of the things that I've written so far apply, at least in some sense, to both renderers. And there's nothing that's really open Cairo specific so far. Maybe some things. I'm not quite sure. I forgot everything. It's been too long. I'm writing this since February, 2 months. Okay, but to be fair, we're taking breaks all of the time. It's only recently that I've started to come back to this and then really push for this being finished. Yeah. So thanks for suffering with me through this, chat. It's more enjoyable when people are here and chatting a little bit. All right. Yo, should we... I could play either Vampire Survivors or we could play some GeoGuessr, and I kind of feel like GeoGuessr right now. I think I'll play a round of GeoGuessr at least. And then we can see, maybe we swap to a late round of Vampire Survivors afterwards. I'll refill my water. So in case you have any thoughts about what exactly we should play now, let me know and I'll be right back. Okay, back. Okay, this is looking good. The pre-commit CI is not complaining about the type or anything, so we can leave this be for now. Good. Close. Welcome back. Thank you, thank you. Thank you. I think we will go and play some GeoGuessr now. And when I say GeoGuessr, I mean the one that I usually play. We shall have to find out again what it exactly was. Because I forgot. How are my key bindings broken again? Why do they always break? I hate that. Wait, did I do something wrong? Maybe. Nope. Broken. That's sad. So OBS key bindings broken again. Okay, for GeoGuessr, what do we need? We need browser. And that's it. Easy. Have that already. We open up Geotastic. Create local game. Accept. Standard. 3 minutes, 5 rounds. Sounds good. Okay. Local game is set up. Now let me quickly change category and stuff. I forgot my key bindings are broken.